Hello, Physionic. Hello, welcome to the dedicated podcast. Today I've got two things I want to discuss. The second thing is going to be housekeeping, so I'll go ahead and jump into the main topic, which is the Nobel Prize. The Nobel Prize was awarded about 2 weeks ago, something along those lines. I posted a graphic about what the researchers that were given the Nobel Prize in medicine and physiology. Obviously, I'm not going to be covering the one for chemistry or for physics because, well, that's not what I espouse to be interested in and what I espouse to be a quote unquote expert in. So, but the Nobel Prize committee met, and if you're not aware of what the Nobel Prize is, it's kind of like the Oscars for actors and directors and individuals of that sort. But I would argue that the Nobel Prize is probably more prestigious than the Oscars because you have a number of different Oscars that go out for different categories. The Nobel Prize is, if you do research in medicine and physiology and genetics and really just anything related to the human body, then you have one Nobel Prize. So if you win it, it is a massive, massive deal. And then the individuals who win it, there's three maximally that can win it. So if you have 4 or 5 people that worked on this particular project that kind of pushed human research forward, then it's really limited to those 3. So only 3 people can win it or less. And this particular research I went over on Instagram. So that's another reason why I plug my Instagram from time to time, is because I release stuff that I don't release on YouTube or podcast. So I try and cross-pollinate between platforms, but I don't always. I have some unique content that releases for each platform. So be sure to follow me on Instagram. You can find that linked if you're listening on podcast or if you're watching this as well. But anyways, what did these individuals discover that won them the Nobel Prize? So the individuals who won were William G. Kaelin Jr., Sir Peter J. Ratcliffe, and Greg L. Semenza. Those 3 individuals working in different labs at different locations discovered that oxygen, essentially the sensation of oxygen by our cells. So how do cells sense oxygen? You might think that's a relatively small thing, but in reality it was a big deal. It is a big deal because oxygen is important for so many different cellular processes, from signaling all the way to mitigating cancer, to metabolism, to all kinds of different things, that understanding how cells sense oxygen, or at least one of the mechanisms by which it senses oxygen, can give us a ton of information on how to combat cancer, for example, because certain cancers are highly oxygen dependent and others are less oxygen dependent. So that's just one example of thousands that I can come up with. So how do cells sense oxygen? I'm going to give you a real overview, so it's not going to be overly in depth. It's going to take me a very short period of time to explain this. If you know more about this, feel free to comment, but certainly know that I am not going into this with any great depth. So oxygen comes in from the outside of the cell, across the cell membrane to the inside of the cell, and there it's turned into what's called a hydroxyl molecule. So you have oxygen, and then it's converted through a reaction to a hydroxyl, an OH. So oxygen is O2, so what's O2 in a biological system, and then it was converted to the addition of a hydrogen to make it a hydroxyl group. So then this hydroxyl will then bind to 2 different molecules kind of in a complex, so meaning that they all kind of stick together and they function together, called HIF1 and VHL. So both of those molecules, both of those proteins will combine together with the hydroxyl group, the hydroxyl molecule attached to it, and then that will create this complex, which is then a signal to then be destroyed by the cell. Seems a little weird, but that is how it functions. And there are a number of reasons for that. I'm not going to go into them in this podcast episode, but this complex is then degraded into its smaller parts to be recycled. So if you have high or normal levels of oxygen, that's how it's sensed, and then this complex is destroyed. Now, if it is low oxygen, if you are in a low oxygen environment or the cells aren't getting enough oxygen, meaning that they are in a hypoxic situation, hypoxia is the term for that, then the HIF1 will not bind as much of these hydroxyl groups. And because you don't get that complex formation, because you don't get this O2 being converted to OH and then OH binding to HIF1, HIF1 will move from inside the cell to inside the nucleus of the cell, which has its own membrane, has its own envelope, which separates the DNA that's inside the cell from the kind of the other meaty aspects, the other areas of the inside of the cell, called the cytosol. I'm just giving you a few details on where these things are happening. HIF1 will move, or what's known as translocate, to the nucleus, where it will bind particular genes that it can bind. So it's a transcription factor. The reason why is it's a factor which binds to genes which will be transcribed into mRNA, a different type of molecule, which is then translated to protein and so on and so forth. But the specific genes is what's interesting that it binds to. The specific genes are genes that will increase the amount of red blood cells, as well as metabolic adaptations, as well as more blood vessels. So really anything that can possibly increase the amount of oxygen that's delivered to the cells. That's essentially what those genes are going to do. Recruit and generate factors that are going to lead to more oxygen being delivered to the cells. The cells are saying, hey, we're not getting enough oxygen. Therefore, we're sending all these signals. Hey, come here, give us more oxygen, have more red blood cells with oxygen bound to them to come to that particular cell and deliver more oxygen so that this complex can form and we can be more in a homeostatic system. So that was the discovery, and that is what won the 2019 Nobel Prize between these three gentlemen. Interesting. To me, it's not the most interesting Nobel Prize discovery, but it is certainly up there. It is an interesting Nobel Prize discovery, and I certainly understand why they won it. So congratulations to them. And until next year, I'm really pumped to find out what the next scientific discovery worthy of the Nobel Prize and winning $1 million as well. On top of that, not only do you win the Nobel Prize, which I've always thought if I won the Nobel Prize, which is likely never going to happen, but if I were to ever win the Nobel Prize, I wouldn't really care that much about the money. It's just the prize itself. The meaning behind the prize would mean so much. I mean, you are in a class of incredibly rare scientists. You are among the most intelligent scientists in the world that have ever existed, that have ever stepped on this earth. So really, really unbelievable achievement. So congrats to them. Now, the second thing I wanted to discuss is the Examine series. I've been really thinking about this, and something that's been bothering me for a while now is the Examine series are kind of hit and miss. Well, they're more hit than they are miss, but I find that the Examine series, if you're not familiar, is the series where I dissect a paper. I read a paper, dissect it, create a ton of notes on it, on different figures, and I upload it on the website with all my notes. And then I create a lengthy video where I explain all the experimental methods and explain each one of the figures, what they mean, the conclusions, and all that. So it's a full breakdown of a paper. Now, while I do enjoy reading the research, that is the main goal of Physionic, to be science-based. So reading the papers and being as transparent as I possibly can, there's a frustrating aspect in that I spend 5 to 6 or more hours of editing some of these 20 to 30 minute videos. And it can be incredibly discouraging, not only because of the views tend to be lower, and I certainly understand because not everybody wants to go through every single figure with me. I completely get that. However, what's more frustrating to me is me spending 5 to 6 or more hours editing these videos when I could be spending that time reading more research, which would allow me to churn out and to really create a lot more content that is unique every week, meaning that I'm not regurgitating, and that's a huge point of pride for me, that Physionic is not churning out the same content every week like you see with many other brands. So I'm constantly trying to evolve, constantly trying to learn more, and through that being able to create new content that's going to be discussing all kinds of different concepts. And of course, as I get requests, it's also difficult for me to be able to spend time reading research on those requests of what people want to learn about and what people want to know more about, and that I can offer an explanation that's absolutely science-based and has a foundation in science. So what I'm thinking about doing is changing the Examine series so that I will still be reading the papers, I will still be taking notes, diligent notes, I will still be uploading those notes with the experimental methods, as well as a breakdown of each of the main figures, as well as the conclusions. But instead of making a lengthy 20 to 30 minute video, what I'm thinking about doing is cutting up several of the figures that I find most telling and starting to create smaller bits of information that pack more of a punch but are shorter. And that means that I'm going to be cutting out the experimental methods section, as well as a lot of the introduction that I would normally do for a full-length Examine series video. And that way people get the information quicker. It shortens my editing time substantially, but it also increases substantially my amount of time that I can sit here and read research, new research. So then that's because I can technically read anywhere from like 7 to like 15 papers a week, but yet you see videos on 1 or maybe 2 papers a week because it's just so overwhelming, crippling. The editing process is just absolutely crippling. So to the productivity. So I think that's how I'm going to switch things. And then the Examine videos themselves, not the extracts, but that I'm going to be releasing, but the Examine videos themselves are probably going to be a hybrid between the Nick research reviews, wherein I've read 10 to 20 to 30 to 40 papers to come up with the article and come up with a short video, and the extracts, which are just based on a single paper. So the Examine series will hopefully, and I think I'm still working through this, but I think they'll end up being like a combination of like 3 or 4 or 5 different papers on a particular topic to give them more power, to give them more a stronger basis of a stronger foundation with which then, with those 3, 5, 6, 7 papers that are involved in that video, then I can be a lot more certain that the results that I'm giving at the end of the video are more certain that those are correct results. Those are correct interpretations of the data. So that way I can strengthen Physionic's brand in terms of the science behind it. I can increase the amount of research that I'm putting out for you guys. I'm still keeping myself open to criticism where it's warranted. If people have problems with a paper, an extract that I release, then they can let me know and I can make amendments in the notes, just like I have been for the examined content up until now. And then, of course, the Nick series won't change. Those release whenever I have the time to write and read and write an article, and then being able to produce and video edit a video for those articles. So that's where I'm thinking, that's where my mind is going. But essentially what I'm saying is that I'm going to be releasing a lot more content, a lot more new content based off of papers. And I hope that you're okay with not having me explain all the experimental methods and whatnot, and that you can still see them all in the notes section where I've broken everything down. And I'll mention a few key points throughout the extract videos as well, because that's just necessary. And I hope that if you have any ideas on how I can be more transparent without video editing too much more, then I would be happy to hear it, because I would love to make this. Again, the point is to be as transparent as possible, to be as science-based as possible, to be as flexible as possible, because I don't want to be stuck in any one point of view. As long as the science follows it, I'm okay with it. But if I start seeing dissenting opinions in the literature, then I have to reconsider my point of view. And I think that's how everybody should be going about their thought process when it comes to science-based literature. Anyways, that's where I'll end things. Thank you if you've listened all the way up to this point. It's been about 17 minutes of me talking, but I certainly appreciate it. I deeply appreciate your support. I know I say that, but I just can't get it across enough. It means so much. I know we're only at like around 4,000 subscribers, but to me that means the world. And I know where things are going. I know things are only moving upwards, and that's what matters. We're going to get to a real punch eventually, and I can't wait for that day to come. But until now, continue to progress and continue to evolve Physionic to be the best version that we can be, that we can learn our body. Okay, with that said, thanks for stopping by. I hope you have a wonderful day, and I will speak with you in the next one. Have a good one, guys. See ya.